car is moving at the speed limit when the driver feels a shake and all of a sudden the wheel blows out. The car then gets slower and slower until it stops 60 seconds after the tire went flat. The driver calls roadside assistance but gets bored waiting, and they start to wonder how much distance they covered between when the tire exploded and when their car stopped moving. How could they figure it out if they don't know where exactly along the road their tire went flat? Well, take a look at this graph of the car's velocity over time. At 30 seconds, the car has a velocity of about 23 meters per second. This means that for this second, the car travels about 23 meters. This is true for every point along this curve. Imagine if we could find the velocity at every second mark along this whole graph and add them all together. We're getting close to the total distance then, but if you think about it, it's still not quite accurate. On top of the velocity at each second, there's also the velocity the car has in between those seconds, the velocity at each half second, and half of that, and so on and so forth. Enter the integral. Integrals allow us to add together the distance the car travels at each split second infinitely close together. Notice that when we do that, what we end up finding is the area underneath our curve. An integral looks like this funny little squiggle here. The numbers at the bottom and top tell us what time frame we're looking at. So for our driver, it says 0 to 60 seconds. This equation is for your curve. This integral can then be plugged into a calculator. And so our driver can find that they traveled exactly 1,240.8 meters by plugging this handy integral equation into the graphing calculator they keep on their person at all times. That's about 0.77 of a mile. Phew, and here's roadside assistance to take our driver to safety.